This week we move to Cycle 1A, which is on probability and statistical literacy. And the first section I'm going to do is 1.8, which covers means, which most students have already learned about. So this is probably going to be a review for you. The mean, or the average, of a set of numbers is one measure of the set's center or middle. It's the sum of the values divided by the total number of values. So here's an example. If Peyton Manning threw a football 85 times for 769 yards total, then he averaged 769 divided by 80, not 85 rather, about a little bit more than 9 yards per throw. There are other measures of the center of the data set that we'll talk about later in this cycle, but for right now we're just going to focus on the mean. So here's a graphic that shows enrollment in Chicago community colleges in 2014. What's the average enrollment? So if we look at the top of each bar, it's a bar graph. They've actually written down what the actual enrollments are. So for us to find the average, what would we do? We would add up those numbers and divide by the number of colleges, which happens to be 7. And if you notice on the graph, they did that calculation, and they show it here as a dotted line across there. So you can see that 4 colleges were below the average and 3 colleges were above. So again, we're going to add them all up. We add all those numbers up, which comes out to a total of 100,313. We divide by 7, and we get an average of about 14,300 students per college. And here's a little bar from your book on page 57 that gives you a little idea of how to calculate. So let's work a couple of problems here. 8 servers work at a restaurant and earn the following tips on a particular night. So we've got a series of numbers here. If their practice is to evenly share the tips, how much should each server receive? So if they're going to share their tips evenly, what would we do? We'd find the mean. We're going to add up all the tip values, there's 8 of them, and then divide by 8. And so they're going to each get a little bit more than $88. Now the median is another measure of the average or the center of a data set. It's the middle value in the data set when we arrange the data values in ascending order from smallest to largest. So if we go back to that tip example, we had 8 numbers, remember, if we put them in ascending order. Now since there's an even number here, the median is going to be the average of the middle two. It's going to be the average of the 4th and the 5th data value. And in this case, it comes out to be a little bit more than $80. And remember when we did the mean on the data set, it was $88. So the median here is a little bit lower. Another measure of the typical or most common value in a data set is called the mode, which is actually the most frequent value in a data set. So here's the data set. We want to find the mode. So we look at the data set and we see if there's any data values that appear more than once. And we notice there is one. It's 43. Some data sets will have one mode, some will have no modes, and some will have more than one mode. So the mode is something that may not appear for a data set. It can appear once or it can appear more than one time. So in this section we learned how to calculate the mean, the median, and the mode. Okay, and then we're going to do section 1.5, which is on probability basics. And the relative frequency is the number of times an event occurs. So it's the ratio formed by the frequency divided by the total number. So for instance, if 15 women in a group of 75 were diagnosed with cancer, then the relative frequency of getting cancer in that group is 15 divided by 75, or 0.2, or 20%. And in this section, we'll do the relative frequencies as the simplified fraction. And in this case, that simplified fraction would be 1 over 5, the decimal, or the percent. And notice to get from the decimal to the percent, we multiply by 100. Here's an example. A national survey asked how many people were living in the respondent's household. The table below shows the results. Find the relative frequency of households with more than 8 people and interpret it. So the first thing we need to do is interpret what they mean by more than 8. So the household sizes range from 1 to 11. More than 8 would mean more than 8 people, so it would be the 9, the 10, and 11. And we see there's 5 respondents that said there were more than 8 people in their household. In order to find the relative frequency, what else do we need to do? We need to add up all the respondents that answered this particular survey. They didn't give me that number, so I would have to add those numbers up. And when I added all those numbers up, I got 2538. That becomes my denominator, the total number of people who responded. And then the numerator were the number of respondents who said their household had more than 8 people, which is 5. So here's my fraction, there's my decimal, and there's my percent. I'm sorry, I didn't give you the percent. I apologize. It would be, if I multiplied by 100, it would be 0.2%. I did not show that here. So approximately 2 out of every 1,000 households have more than 8 people. So experimental probability tells us the likelihood or the chance of something happening. Relative frequencies tell us the percent of the time something did happen, and these can also be called experimental. They're also called empirical probabilities. These are percents that can be used to say what percent of the time we expect something to happen. And this is where we have to actually collect the data to give us the answer. And next week we'll learn about theoretical probability, like rolling a die or drawing a card from a card deck, where we don't have to actually do an experiment or a trial to get the relative frequencies. So for instance, a recent survey showed 40% of Americans approve of the job the president is doing. In other words, we expect 40 out of every 100, or 4 out of 10, or 2 out of 5 Americans to approve of the job the president is doing. You can interpret this in an experimental probability and say that if you randomly pick an American, you would expect to get someone who favors the president about 40% of the time. So here's an example. Recently, a poll was conducted to try to understand consumer coffee habits. Complete the following table. So we have the respondents classified by their age, and we have whether or not they said they drink at least 1 cup per day and whether they said they didn't drink any coffee per day. And we want to fill in the missing cells. So let's take a look what we were given. We were given the total in each age group, so we could add those up to get the overall total. In each age group, we were given how many people said they drink at least 1 cup per day. So to find out the number of people that don't drink 1 cup per day, how can we do that? We can take the total in that group, that age group, and subtract the people who said they drank 1 cup per day. And we can fill in those numbers. I can also add these numbers up to get the total here. And so the 387 again came from taking 744 minus 357. I can take 519 and subtract 342 and I get 177. I can take 266 and subtract 196 and I get 70. I can add those numbers up. I can add this number plus this number to get the total, and I can check the total by adding these 3 numbers together and make sure I get a number that agrees. So now we can find experimental probabilities from that table. Find the experimental probability that someone in each age category drinks at least 1 cup per day. Which age group had the highest probability? So if you go back and look at the table, in the 18 to 44-year-old group, there were 744 respondents, and 357 said they drink at least 1 cup per day, which is about 48%. In the 45 to 54-year-old group, there were 519 respondents, and of those, 342 said they drink at least 1 cup per day, which is about 66%. And in the 65 plus group, we had 196 out of the 266 who responded, and that is approximately 74%. So what can we say? We can say the 65 and older group has the highest probability of drinking at least 1 cup per day. Find the experimental probability someone over the age of 65 does not drink at least 1 cup per day. What's the fastest way to find that? So if I just flip back for a second, remember 74% drink at least 1 cup per day. So what percent don't drink 1 cup per day? I can look at the number in the little table I had. It was 70 over 266, or about 26%. But I also know, this is what I just said, 74% drink at least 1 cup. So if I subtract that from 100, I also get the 26%, the remainder of that group, that don't drink at least 1 cup per day. So 2 different ways to calculate that answer. Find the overall probability someone 18 or older drinks at least 1 cup of coffee per day. So in this case, let me just flip back real quick to the table. We're going to the very bottom row on the table here. We're going to go down here and we're going to take 895, the overall probability, and divide by 1529. And remember some of the numbers we had here. 48, it was going up 66, 74. And so when we do the overall, it comes out to be 59. So it's in between those numbers. So overall, 59% of people say they drink at least 1 cup of coffee per day. So that's a review of the concepts in sections 1.8 and 1.5, and that's the beginning of our cycle 1A on probability and statistical literacy.